Dear students, today we'll discuss about multiples and submultiples of SI units. While you are measuring very large quantities or very small quantities, then you need multiples or submultiples of SI units. For example, the distance between two cities, let it be 50 kilometer. If you want to express in SI unit, the unit SI unit of distance, you know it is meter. In meter, the distance will be 50,000 meter. So you see these two numbers, which one is easy to express? 50 kilometer is easy to express or 50,000 meter is easy to express? Definitely 50 kilometer is easy to express. Then what is done here? You see here meter, here we are adding only k, the prefix k to meter. That means it is kilometer. This k stands for kilo. That means here we got the multiples of SI units. Similarly, if you find the size of the particle, the size of the particle, let it be 10 to the power minus 9 meter. If you want to express nanometer, then it is 1 nanometer. You see, which one is easy to express? 10 to the power minus 9 meter or 1 nanometer? Definitely 1 nanometer is easy to express. Here, you have added n, the prefix n to meter. Here it becomes nanometer. When you add the prefix n, then you got the submultiple of SI unit. When it is positive side, it is 50 into 10 to the power 3 meter, 10 to the 3 meter per kilometer. That means positive 10 to the power positive side means positive power, that is multiple, and negative power, that is submultiple. That means multiples and submultiples of SI units can be obtained by adding the prefix to the SI units. So here I have listed a number of prefixes. Here for this column is for submultiples and this column is for multiples. First one is your prefix, first come to submultiples, prefix, symbol, then value. That is, first one is your deci, symbol is small d, value is 10 to the power minus 1. Centi, small c, value is 10 to the power minus 2. Milli, small m, value is 10 to the power minus 3. Micro, mu, value is 10 to the power minus 6. Nano, small n, value is 10 to the power minus 9. Pico, small p, value is 10 to the power minus 12. Then femto, small f, value is 10 to the power minus 15. Then octo, small a, value is 10 to the power minus 18. Now come for multiples. First column is your prefix deca, symbol is da, because small d is for deci. When it is da, then it is deca. Deca, the value is 10 to the power 1. Hecto, small h, value is 10 to the power 2. Kilo, then small k value is 10 to the power 3. Mega capital M, because small m for milli and capital M for mega. Then capital M value is 10 to the power 6. Then giga, capital G 10 to the power 9. Then tera, capital T, then 10 to the power 12. Peta, capital P for peta and small p for pico. Then it is 10 to the power 15. Then hexa, that is capital E, value is 10 to the power 18. So now, if I will ask one micrometer, micro, you see, you have to remember these symbols. It is the symbol of micro. You see, micro, that is 10 to the power minus 6. That is 10 to the power minus 6 meter. If you write 1 micro joule, that is 10 to the power minus 6 joule. Similarly, if you write 1 micro coulomb, then 10 to the power minus 6 coulomb. Similarly, if you write 1 millicoulomb, small m is milli, that is 10 to the power minus 3, 10 to the minus 3 coulomb. Similarly, if you write 1 picofarad, small p is for pico, 1 picofarad, that is 10 to the power minus 12 farad. You see, small p for pico and it is 10 to the power minus 12. Similarly, if you write 1 capital MJ means megajoule, that is mega, that is 10 to the power 6, 10 to the power 6 joule. If you write 1 small kj means kilo joule, 10 to the power 3 joule. If you write 1 kilometer, already told, that is 10 to the power 3 meter, means where small k comes, means kilo comes, then multiple is 10 to the power 3. If you write 1 small kc kilo coulomb, then also it is 10 to the power 3 coulomb. That means whenever you have the prefix small k, that means it is kilo, then the multiple comes, that is 10 to the power 3. Similarly, whenever you have capital M as the prefix, then the multiple comes, then it is 10 to the power 6. When you have small n as the prefix, then that is the nano, then the submultiple comes, that is 10 to the power minus 9. The negative powers of 10, that is called as submultiples, and positive powers of 10, that is called as multiples. Now come to, so you remember all these multiples and submultiples of SI units. Some practical units for measuring small distances. First one is your Fermi. While you are asked what is the size of a nucleus, you remember the nucleus size is very small. That is 10 to the power order of 10 to the power minus 15 meter. If you say it is 10 to minus 15 meter, then it is difficult to express. Instead of 10 to the power minus 15 meter. If you say it is Fermi, then it is easy to express. You remember 1 Fermi, that is 10 to the power minus 15 meter. It is used for the measurement of the size of the nucleus. Now come to angstrom. You remember 1 angstrom 10 to the power minus 10 meter. It is easy to say 1 angstrom than to say 10 to the power minus 10 meter. This unit is used to measure the wavelength. Now come to nanometer. 1 nanometer, that is 10 to the power minus 9 meter. Already told, nanometer is 10 to minus 9 meter. It is another smaller unit of distance. It is used to measure the size of the particle. You have now you have very small particles whose size falls in the order of 10 to minus 9 meter. It is easy to say nanometer than to say 10 to minus 9 meter. Also it is used to measure the wavelength. Then micron, that is micrometer, that is 10 to the power minus 6 meter. It is used to determine the size of the particles, micro particles, small particles. Now come to some practical units for measuring large distance. For example, if you are asked to find the distance between two stars, two planets, in unit meter, you will get a big number. It is difficult to say. That's why there are some practical units, some other units to express this large distance. The distance between two stars, distance between two planets, between the sun and the earth, that different units we are using. First one is your light year. Light year, you remember, just it looks like it is year. You know, year is the unit of time, but this light year is not the unit of time. You remember, it is the unit of distance, big unit of distance. What is light year? It is the distance traveled by light in vacuum in 1 year. You know, the light has the speed that is 3 into 10 to the power 8 meter per second in vacuum. In 1 year, you know, that is 365.25 days. If you want to express in hour, then 365.25 into 24 hours. And 1 hour is 3600 seconds. So 1 year becomes this much of second. And 1 light year, just told, it is the distance traveled by light in vacuum in 1 year. That means to get the light year means distance, you have to multiply speed of light with the time. Speed of light, that is this one, 3 into 10 to the power 8 into this number, that is the time 1 year, that is 365.25 into 24 into 3600. It's the speed of light in vacuum and it is the time in second. Here we have converted year to second. When you multiply all this, you will get 9.467 into 10 to the power 15 meter. You remember this. 1 light year is this. 9.467 into 10 to the power 15 meter. Now come to astronomical unit. It is the mean distance between the sun and the earth. You know, if it is sun, the earth is revolving around the sun in the elliptical orbit with the sun situated at one of its foci. So the distance of the earth is not same always. If here it is maximum, here it is minimum. So the mean distance between the sun and the earth is the astronomical unit. One astronomical unit, that is, you remember, it is 1.496 into 10 to the power 11 meter. Now come to parallactic second. It is also another unit to measure the large distance, and you remember it is the largest unit of the distance or the biggest unit of the distance. What is this parallactic second? It is the distance at which an arc of length, one astronomical unit, subtends an angle equal to 1 second of arc. Repeating again, it is the distance at which an arc of length 1 AU, means astronomical unit, which subtends an angle 1 second of arc, that is 1 arc second. Here you see, it is suppose the arc, this arc has the length 1 AU. Suppose that arc subtends an angle equal to 1 second of arc. 1 second of arc. Then this distance is your 1 parallactic second or 1 par second. That means if you take it is theta, it is L, it is R. That means R is equal to L by theta. R is, you see, the distance is a par second, 1 par second, and the arc length you see 1 AU divided by theta, 1 second of arc or 1 arc second. 1 arc second. When you convert or 1 par second, astronomical unit you write in terms of meter, that is 1.496 into 10 to the power 11 meter divided by, it is 1 arc second. It is not the SI unit of angle. SI unit of angle is radian. You have to convert second to radian. You know 180 degrees pi radian. 1 degree is pi by 180 radian. 1 degree, that is 60 minute, is equal to pi by 180 radian. That means 1 minute means arc minute, this arc minute or minute of arc. That is pi by 180 into 60 radian, or 1 minute, you remember, that is 60 second. 1 arc minute is 60 arc second. So 1 second of arc, that is pi by 180 into 60 radian. You put this value in this equation, because in the denominator we have 1 arc second, that is pi by 180 into 60. When you calculate, you will get 3.08 into 10 to the power 16 meter. These three units, that is light year, astronomical unit and per second, are the practical units for measuring large distance. Now come to how to measure this large distance. You cannot measure the distance between the sun and the earth by using a measuring tape or measuring scale. We have to adopt indirect method to measure this distance or these large distances. So one of the indirect method is method of parallax. Indirect method for measuring large distance. First to take parallax. What is parallax? You see, you hold a pen in front of your head like this. You have two eyes. When you close this eye, then your point of observation is this eye. When you close this right eye, the point of observation is your left eye. Alternatively, you close one eye and you see from other eye. Then what you are observing? What you are observing? You see the line of sight or the position of pen changes. You see the position of the pen changes. Why this position changes? Because when you close left eye, then you are seeing from right eye. You are seeing from right eye. The line of sight is this. When you close right eye, your position, your observation point is left eye. Your line of sight is this one. So when you close one eye and see from other eye, then point of observation that changes. That's why the line of sight changes. And this apparent change in position due to position, repeating again, the apparent change in position of object due to change in position of observation is called as parallax. The apparent change in position of object due to change in position of observation is called as parallax. Suppose your point of observations are at here, let it be A and it is B, and your object is at here. If you are seeing from this, line of sight is this, if you are seeing from this, the line of sight is this. This distance between two points of observation, that is called as basis. B is your basis. It is the distance between two points of observations. And this angle, that is your parallactic angle. Parallactic angle. Let the distance OP, that is your S. That here you can use theta is equal to B by S to know it. By using this formula, you can measure either one if another two are given. If B and theta you have, then you can find S. If S and B you have, you can find theta. For example, to measure the distance of the moon from the earth, suppose it is moon, position of the moon, it is the earth. If you are seeing from here, if the line of sight is this, and from here the line of sight is this, then this distance you know, let it be B, and this angle you can measure. Then you can find the distance of the moon from the earth, let it be S. Then theta is equal to B by S. Theta is equal to L by R. Then you can find S is equal to B by theta. So it is your method of parallax to measure large distance.